Hello everyone. First things first, we're going to begin with the instructions on how to submit your homework assignment. First and foremost, please, whenever I give assignments, follow the instructions. The instructions will be given either through Kakao or in text message format. If I did not give you the instructions in Kakao, then they will be in the videos that I produce for this class. Please do not ever send me messages after 6 p.m., especially not 1 a.m., 2 a.m., or 3 a.m. This will be your only warning. Anyone who sends me messages after 6 p.m. will lose points on their score. Hopefully there are no questions about that. If you want to contact me during the daytime, I'm always happy to answer your questions. If, however, you send me messages at night, you will lose points. Hopefully everyone is very clear on that. Now, moving on. Your homework assignment was due or is due today. You have 15 minutes. 15 minutes from the beginning of class to submit your homework assignment. Your homework assignment should be submitted by email. Here is my email address, jessekull@hotmail.com. jessekull@hotmail.com. Please submit it. Please put your name, your class time, for example, Tuesday, 1 p.m., and your student number in your subject line. So 3 things: your name, your class time, your student number in your subject line of your email. You have until 10:15, 15 minutes from the beginning of class, if class begins at 10 o'clock. If class begins at 1 o'clock, you have until 1:15. If class begins at 3 o'clock, you have until 3:15. You have 15 minutes from the beginning of class to submit your homework assignment. Hopefully everybody is very clear on that. After that 15-minute period has passed, your homework assignment will be considered late. Your homework assignment should be finished by now, and as soon as you see this, you should have no problem sending it to me. But I've given you a slight 15-minute grace period just in case there are some issues. But 15 minutes should be enough to solve all your problems if your homework assignment was finished properly on time. Okay, if there are any questions about that, if you have any emergency problems, not finishing your homework is not a problem. That is your mistake, not mine. But if something has happened, you have several minutes to contact me. Please contact me by Kakao Talk. All right, moving on. Today we are going to review for our midterm exam. Not final exam, sorry, our midterm exam. First, to begin, we're going to look at recover break-even analysis. This will be your first major topic that you'll be responsible for on your midterm exam. Break-even analysis was an analysis conducted to determine the number of units that need to be sold before an item stops losing money or breaks even. Now, to do that, we need to consider 2 different costs, both fixed and variable. Fixed costs are those costs that do not change depending on how many units are produced. Variable costs are the costs that do change depending on the number of units produced. We'll look at both in a little more detail here. So, fixed costs are those that do not fluctuate with the level of production. It doesn't matter how much you produce, it doesn't change. These are the costs that have to be paid no matter how many goods or services are produced. Fixed costs can be anything, but common examples include rent, insurance, machinery investment, etc. These are the costs that you have to pay, and it doesn't matter if you produce 0 goods or 1,000. And generally they're represented graphically by a straight line on the graph, at whatever level the fixed costs might be. So if your fixed costs are $10,000, it is a horizontal line drawn at the $10,000 mark. Variable costs are those that vary depending on the number of goods or services produced by a firm. They increase at a set rate. So it's $1 per unit, $10 per unit, $1,000 per unit, 2 cents per unit, etc. It's a per unit rate. When we're doing it, variable costs, when we're doing it graphically, begin at the level of fixed costs because our total costs can never go below our fixed cost level. Examples of variable costs, again, can be anything, but generally represented by electricity, materials, labor, any cost that increases or decreases depending on the amount produced. The variable cost line, as I said, begins at the fixed cost line and increases at the rate of cost per unit. That's what we see here. Total costs are the collection of both fixed and variable. For a break-even point to be established, our revenue or profit has to equal our total costs. Now, total cost is our fixed cost that remains stable plus our variable costs. This is, we see here, total cost is both variable plus fixed, and it increases depending on the number of units sold in accordance with the variable cost rate. Now, what we have to do to determine our fixed costs is determine where revenue equals our fixed total costs, fixed costs plus variable costs. Revenue is the amount of money or profit generated per unit or service. It's a rate, $5 per unit, $3 per service, $10 per unit, $100 per service, etc. This is considered visually in the next slide. Here we see our total revenue line. It begins here at 0 because if we produce nothing, we make nothing, and it increases at the total revenue ratio. It increases at the rate that total revenue increases, $100 per unit, $3 per unit, etc. And where total revenue is equal to total cost, this is our break-even point. This is where we're not losing any money and we're not making any money. So a break-even analysis is attempting to determine how many units we have to sell before we break even. As I said, we need to know 3 things: our fixed costs, our variable costs, and our revenue per product. Now, we can be missing any one of those 3 and determine it. But to find our break-even value, we need all 3 of these. This is basic mathematics. At times, we will have to interpret. If we're given our break-even point, but not given our fixed cost, we may have to determine our fixed cost. On the midterm exam, questions like that might be possible. I may give you one aspect of the break-even analysis, but not the aspect of it that you are expecting. In that scenario, you may have to solve for the missing ingredients. Okay, hopefully everybody's clear on that. Our break-even analysis formula is given here. We have three figures listed. Break-even quantity is the number of goods we must sell, and break-even quantity is equal to fixed cost divided by sales price per unit minus variable costs. Another way to look at that is fixed cost minus or divided by profit per unit. Profit per unit is found by variable sales price per unit minus variable cost per unit. If our sales price is $100 and our variable cost is $10, it's fixed cost divided by 90, our profit per unit. This is the simple equation that you do have to remember. You will have to know for your midterm exam. Your break-even quantity is equal to fixed cost divided by sales price per unit minus variable cost per unit. An example of a break-even analysis. Colin is the managerial accountant in charge of Company A. They sell water bottles. The fixed costs of Company A, property taxes, lease, executive salaries, are $100,000. The variable cost with producing a bottle of water is $2. The water bottle is sold at a premium price of $12. So to find our break-even point, we have 100,000 divided by 12 minus 2. 12 minus 2 is 10, so 100,000 divided by 10 equals 10,000. In that situation, this very standard question, we have quite simply a break-even quantity of 10,000. Okay, hopefully everybody is clear on this. This is our break-even analysis graphically, the one we just solved. We see that we have 100 at 10,000 units. We are breaking even because our total costs equal our revenue stream. Our fixed costs are even at 100,000. Our total costs climb at a ratio of $2 per unit. So at 10,000 units times 2, we're at 120,000 in total cost. At 120,000 in total cost, revenue is equal to total cost. This is our break-even point. To explain it very briefly, the number of units on the X is on the X-axis right here. And the number of, or the dollars is on the Y-axis. The red line represents the fixed cost. The blue line represents revenue per unit sold. The yellow line is total cost, which is fixed cost plus variable. The break-even point is at 10,000, as we can see here. And when the number of units exceeds 10,000, we're in a situation where the company is now making money. That's where revenue has now exceeded total cost. Below that, below 10,000 units, revenue is below total cost, as we can see right here. So below 10,000 units, we see that our total revenue line is below our total cost line, and that means we're losing money. Above 10,000 units, now revenue is above total costs, and that means we are making money in that situation. This is essentially break-even analysis. There will be a random number of break-even analysis questions on your exam. You are expected to be comfortable with the theory governing break-even analysis, as well as the basic problem-solving methods associated with break-even analysis. Now, moving on, we're going to cover each of our 9 daily attendance quizzes to begin. Attendance quiz number 6. Another word for constraints is option, restriction, or parameter. Another word for constraint is restriction. A constraint is something that governs our decision making. A restraint is something that limits us. A constraint or restriction is something that tells us what must happen. For example, if I say you have to produce 10 units of X1, that is a restriction. That is a constraint. That is something that determines what you can and cannot consider to be an acceptable solution. If it doesn't meet this, it is not an acceptable solution. If it doesn't meet this restriction, it's not acceptable. So another word for constraint is restriction. To maximize profit, we should produce an unlimited amount, an amount that makes sense, whatever we want. In an unrestricted scenario, in a perfect situation where we have no constraints and no restrictions, we should produce an unlimited amount. If we make X dollars per unit, we should produce infinite units. The only thing that should stop us from producing is constraints or limitations. In this theoretical situation, in this ideal situation, we have no constraints. Simply to maximize profit, we should produce an unlimited amount. Every unit produced increases our profit or revenue, therefore more equals better. If more equals better, we should produce an unlimited amount. The purpose of management science is to eliminate bias and opinion from decision making, bring math into situations. It is unclear at this point. This is the topic I've covered repeatedly, and hopefully everybody's very clear on this, but the purpose of management science is to eliminate bias and opinion from decision making. The goal of management science is to take human error out of the equation. When we are deciding on an optimum choice, we don't want what we think. We want scientific reality. It doesn't matter what you believe will be successful. Some situations we can very simply determine optimal choices mathematically. That is the purpose of management science. Our goal is to take away human error by incorporating managerial science techniques like linear programming, like break-even analysis. We want to eliminate any opinions, any thoughts, any ideas that the management team may have. In the question we investigated, bowls and mugs produced blank and blank profit respectively, 50 and 40, 50 and 50, 40 and 50. This is a question dealing with objective functions. We're going to see this again in these quizzes. You have to have a working understanding of what objective functions represent. Objective functions represent our connection between our ultimate goals and our decision variables. Our ultimate goals could be maximizing profit, minimizing resource usage, etc. But our objective function given in the first line, max z equals 40x1 plus 50x2. That objective function connects our two decision variables, bowls and mugs, to our ultimate goal of maximizing profit. And we see here it's $40 for a bowl, $50 for a mug. That means our correct answer in this situation would be C, $40 and $50 respectively. Okay, there will be quite a few potential objective function questions given to you, and these are the sort of questions that you will have to answer effectively as you essentially solve these problems. All the questions will be randomly generated. No two exams will look the same. You may have the same question as somebody else. You may have a different question. The question order will be randomized. The question solutions will be randomized. So your question 1 could be another person's question 20. Your solution A could be another person's solution C. So I cannot tell you exactly how many objective function questions you will have, but statistically you will have some on your exam. This is a topic you need to be familiar with. Next, we have 2, 3, or even more. We can have 2, 3, or even more decision variables in linear programming problems. Now this is what we've done so far is the very base level of linear programming. It's something that we haven't in many ways differed from. In a lot of ways, we've kind of stuck to the 2 decision variable model. And the reason is very simple. They are the easiest models to solve. We are just becoming familiar with this topic, and it doesn't make sense yet to move on to more complex problems if we haven't mastered the basics yet. Now, one thing to keep in mind is that when we are solving graphically, 2 decision variable problems are very, very simple. As soon as we move beyond that, it becomes difficult to the point of not being useful to solve graphically. So for now, we are going to stick to 2 decision variable problems, but it is possible to have many more decision variables than 2. When you take the continuation of this course, Managerial Decision Making, you will be in a situation where we will have 3, 4, 5, 6, 10, 15 decision variables. But it is not a situation where you have to worry about it now, but for a theoretical exercise, yes, in this situation, it is possible to have even more decision variables than 2. That was our first attendance quiz number 6. Moving on to number 7. The parameters are the numbers attached to variables in linear programming, the rules or guidelines in linear programming, the necessary steps to follow to solve a problem. This is something I have covered, but we're going to cover again very briefly here because it is important and you may have questions related to this on your midterm exam. Parameters are the numbers attached to variables in linear programming. If I say, for example, that we have $200 per table produced, it becomes 200, max z equals 200x1. That 200 represents a parameter. It is the numeric portion attached to our variable, which in this case would be x1, which represents product number 1. So parameters are the numbers attached to variables in linear programming. If we search through a linear programming problem, anytime we see a number associated, so we require 4 units of labor to produce 1 final good, it's 4x1. That 4 represents a parameter. That's something that we have to consider when we are solving our problems. Which one of these is not one of the 3 key steps to translate linear programming problems from natural language to equation format? Constraints, parameters, decision variables, objective function. When we are translating from natural language, when we look at the problem in natural language and we want to turn it into an equation that's solvable using set problem solving techniques, we require several things. Number 1, we require an objective function. Number 2, we require constraints. And number 3, we require parameters. The decision variables are not something that we need to write directly into the equation. They are, however, a part of the objective function, but they are not one of the key components required. Instead, they are part of one of the components, part of the objective function. Next, when gathering all of our information together, it is important to write the equation in the same format, true or false. The answer here, and I've reiterated this, I've touched on this, I've spoken about this time and time again. It is critically important when we are writing our equations to write them in the same universal format. First comes our objective function, then we write the phrase subject to, and following that we list all of our constraints in order. This is critically important when we are translating from natural language into our format that we require to solve the problem. Moving on. When we are solving linear programming problems, the first step is deciding the ultimate goal, true or false. When I was initially instructing you on how to translate from the natural language problems into equation format, we always followed the same steps. The first step was finding our decision variables. The second step was deciding our ultimate goal. Our third step was putting those two together into an objective function. And following that, we listed our constraints. So when solving linear programming problems, the first step is deciding the ultimate goal, true or false. The correct answer in this situation is false. It is false because our first step is not deciding the ultimate goal. Our first step is determining our decision variables. Before we look at what we are trying to find, we have to decide what we are deciding between. Maybe we are deciding between how many products of A to produce and how many products of B. Maybe we're deciding how many of A to purchase, how many of B to purchase. But before we decide if we're trying to maximize or minimize, we have to decide what we are deciding between. So this answer is false. Moving on. What are some other words that do not mean the same as constraints? And again, this comes back to looking at the basic idea of constraints. A constraint tells us what we have to do. Not what we can choose to do, but what we have to do. In this situation, a rule also tells us what we have to do. A guideline also tells us what we have to do. A limitation also tells us what to do. Therefore, options are not the same as constraints. Constraints, as I've said again and again, cannot be ignored. Any solution that we find has to consider constraints to be mandatory. Any solution that does not satisfy our constraints is not a valid solution. Any solution that does not allow us to meet or exceed or, in a minimization, fall under a constraint cannot be chosen. So there are rules that have to be followed, they are guidelines that they have to be followed, and they are limitations that control our decision making. They are not options. Moving on. This is attendance quiz 8. This is the end of week 3. When solving linear equation problems, we should always follow the same basic steps. Now, as I said before, the first step is, when we look at the base level, finding our decision variables. That step should never be skipped. Once we do that, we want to find our ultimate goal. Are we trying to maximize something? Are we trying to minimize something? What are we trying to maximize? What are we trying to minimize? Then we connect the two in our objective function, our ultimate goal, with our decision variables. Following that, we then move on to our constraints, going through the problem, translating the natural language problem into the mathematical equations that we require. This is always universally true. Once we do that, at this base level, we move on to graphing. When we graph, we solve following the same steps every time. We draw our graph, we input appropriate data on the x and y axis, we graph each of our constraint lines, we find where our constraint lines meet the x-axis and the y-axis of our possible optimal solutions. And then we find where they intersect. We then mark all of our possible optimal solutions. Those we can find visually, we do. Those that we cannot find visually, we don't. We use algebraic principles. Once we found them using our algebraic principles, we run all of our possible optimal solutions through our objective function to determine where our ultimate maximization or minimization goal occurs. Every single time we solve a problem like this, we should follow those basic steps. So the answer is true. When solving linear equation problems, we should always follow the same basic steps. One of the constraints in Chapter 2, Question 4 would be 4x1 plus 4x2 is less than or equal to 40. In this situation, we have to look at the question. This is less than or equal to 40, so this would be a constraint. We see here, each table requires 10 units of wood, 4 units of fiber. So 4 units of fiber plus 4 units of wood, and we see that we have 40 units of fiber. Okay, so what we would do in this situation, we have 40 units of fiber, so that's correct. A table is 4 units of fiber. A chair is 6 units of fiber. So in this scenario, 4x1 plus 4x2 is incorrect. In this situation, it's 4 units of fiber. It's 4 units of fiber and 6 units of fiber, and there are less than or equal to 40 units. So in this scenario, the answer is false. To solve problems like this, and you will have problems like this on your midterm exam, you have to be comfortable determining constraints from natural language problems and interpreting them into equation format. This situation is a very basic example, but you will have to be relatively quick because there will be questions similar to this, of this nature, on your midterm exam. Hopefully everybody's very clear on that. Let's look at another example. The objective function in Chapter 2, Question 4 would be, in this situation, to determine the objective function, we need to know 2 things, or 3 things, really. Number 1, what are our decision variables? Number 2, what is our ultimate goal? Number 3, what are the parameters associated with our decision variables? If we remember from several minutes ago, parameters are the numbers associated with our variables in a linear programming problem. So, as I said, we need 3 things. First, decision variable. A carpenter makes tables and chairs. If we go to the last sentence, a table and a chair earn the store $300 and $200 in profit respectively. So our decision variables are tables and chairs. X1 is tables, X2 is chairs. We are trying to, in this situation, we know it's a production question because we're manufacturing, and we're trying to, because it's profit given, we know we're trying to maximize. So we're trying to maximize Z of table and chairs, and we know from the last sentence, a table and a chair earn the store $300 and $200 respectively. So our maximization, our objective function would be max Z equals 300x1 plus 200x2. Looking at our 3 possible choices, the answer is C. Max Z equals 300x1 plus 200x2. B is not possible because our parameters are incorrect and it's a minimization. A is not possible because our parameters are incorrect. So again, if we see a question like this, you have to be able to solve relatively quickly or determine relatively quickly from the natural language question the objective function. There are dang constraints in Chapter 2, Question 5. The Pinewood Furniture Company makes chairs and tables from two resources, labor and wood. First and foremost, in this situation, we have to know immediately constraints are limitations. When we read through the question, we have to search for anything limiting our decision-making process. In this situation, in sentence 1, Pinewood Furniture Company makes chairs and tables from two resources. We have labor and wood. Resources are always going to be limited. So that's a limitation. Those are two limitations. So we know already we have two constraints. The company has 80 hours of labor and 36 board feet of wood available each day. Demand for chairs is limited to 6 per day. So we have another limitation. Chairs is limited to 6. So we have labor, wood, and demand. Each chair requires 8 hours of labor, 2 board feet of wood. Each table requires 10 hours of labor and 6 board feet of wood. We've covered the rest of the question. There were only 3 limitations given to us, so we know the correct answer, A, B, or C, in this case is B. There are 3 limitations. If you find a question similar to this, you have to consider, or you have to look at it and read quickly through the question looking for limitations. What limitations are governing decision making? In this situation, we had 3 things governing our decision making. We had A, limited labor, B, limited wood, and C, limited demand. So we had 3 constraints. Next, what is the maximum number of chairs the Pinewood Company can produce? So in this situation, we're looking for any information that references chairs. The Pinewood Furniture Company makes chairs and tables from 2 resources, labor and wood. The company has 8 hours of labor and 36 board feet of wood available each day. Demand for chairs is limited to 6 per day. Suddenly, we have a sentence that directly references chairs. In this situation, we're saying that the maximum amount that we can make every day is 6. So the correct answer is A, B, or C. The correct answer is A, 6 chairs. If you have a question like this on your exam, if the question directly references one resource, one limitation, one constraint, you should read through the question looking for that constraint. You should read through the question attempting to determine what constraints are possible. What limitations may be placed on that direct idea. In this situation, it was chairs. So we found 1 sentences directly referencing chairs, and we could solve a problem like this very easily. Moving on to attendance quiz number 9. It is important to highlight the decision variables prior to beginning the question translation. As I said again and again, it is critically important to highlight decision variables. The reason for that is because we want to be in a scenario. We want to consider from the very beginning what is the question asking us to decide. Of course, we want our ultimate goal. Maybe it's maximizing, maybe it's minimizing something. But before we can even look at that, we have to consider what is being decided. Remember, linear programming is attempting to determine optimal solutions between different choices. That is the key aspect of linear programming problems. What is the best choice? And our decision variables represent our choices. That's why, very simply, this is critically important. Before we can go into any question, we have to ask, what are they asking us to choose? And what they are asking us to choose between is quite simply our decision variables. So yes, they are critically important. In the first question we reviewed, what was the objective function? So here again, you'll see a question where we have to determine the objective function. A carpenter makes tables and chairs from wood and fiber. The store has 50 units of wood and 40 units of fiber. Each table requires 10 units of wood and 4 units of fiber, whereas each chair requires 6 units of fiber and 4 units of wood. The store has to use a minimum of 20 units of fiber. The demand for tables is no more than 2. Each table is sold with at least 2 chairs. A table and chair earn the store $300 and $200 in profit, respectively. In this situation, we can read through the entire question, like I just did. Or we can strategically attack the question. Objective functions, we know, are comprised of 3 things: decision variables, ultimate goals, and parameters. So, very quickly, we can look at this. A carpenter makes tables and chairs. A table, and last sentence, a table and chair earn the store $300 and $200. So we know decision variables, tables, and chairs. We know the parameters associated with tables and chairs, 300 and 200. And we know because it's a production question and we see how much is being earned, we know that it's a maximization problem. So max Z equals 300 for table, 200 for chair, max Z 300x1 plus 200x2. Part C, or answer C, is correct. When we see questions like this, rather than reading slowly through the entire question, instead we want to focus on attacking the question strategically. We want to focus on looking at what is being asked and searching out that information as quickly as possible within the natural language question. Moving on. In question 2, is it important that refer to the waste by their names, tanning or dyeing, or would waste 1 and waste 2 be equally acceptable? Now, I've listed the entire question. It's a situation, this is a theory question. This is the sort of question that is asking you to understand not the individual specifics of this question, but linear programming questions in general. In a linear programming problem, let's ignore this question for now. And I gave you the question because I want you to actively be thinking about this. In this scenario, the question is not important. In this scenario, instead, it's a basic question governing all linear programming problems. And in this scenario, no, it is not important for them to be governed by their names. Yes, waste 1 and waste 2 would be equally acceptable. Again and again, we're giving names to these situations. Tables and chairs, tanning waste, dyeing waste. Production packet A, production packet B, large package of pepperoni, small package of pepperoni, large ingredients, small ingredients. These are the names given to us in the natural language problems. But the actual reality is that these are not overly necessary. We don't need the names. We can refer to them as waste 1 and waste 2, product 1 and product 2, option 1, option 2. And that's how we can basically think of this. Because they are decision variables, they are quite simply options. Option 1, option 2. Choice 1, choice 2. For us, because we're looking at the problems in a natural language format before we are looking at the problems in our equation format, it helps us to understand or to visually represent them with names that we recognize, like tanning and dyeing, but it's not overly necessary. It can be waste 1 and waste 2. It can very simply be x1 and x2, choice 1 and choice 2. So the correct answer in this situation is A, no, and yes. It is not important to refer to them as tanning and dyeing. Waste 1 and 2 would be perfectly acceptable. In a question where we are manufacturing and a maximum amount of resources available are given, we should assume the question is a maximization, a minimization. It is unclear from the information given. Now, we cannot see the question in front of us. So again, we have a theory question related to linear programming problems. If we are manufacturing, typically we kind of think that we're trying to maximize revenue or maximize profit. However, if we are manufacturing, we could be trying to manufacturing but not waste resources. It could be a minimization problem. But if we give the maximum amount available, then this is what's limiting us from producing a maximum amount, an infinite amount. If our goal would be producing an infinite amount, then we should assume it's a maximization. If our goal is producing an infinite amount but limited resources, a maximum amount is given, then we have to assume it's a maximization problem. The answer is A. In questions like this, these are the type of questions that draw on all of the information I've been giving you for the past 7 weeks. These are the sorts of questions that ask you to fundamentally understand what is being asked. There is no answer we can memorize because there are an immense amount of possibilities. But we have to think carefully. Okay, I'm trying to manufacture. Okay, I have only a limited amount of goods to manufacture. In that situation, we have to understand what is being asked. And in that scenario, what is being asked is quite simply how much we can do to maximize our revenue or profit. You probably will statistically have theory questions like this that ask you to understand the basic concepts that we've talked about. Those draw on information given throughout the past 7 weeks of lecture. Attendance quiz number 10. In the first question we reviewed, is it important to receive vitamin C from oranges? Let's skip. Now again, here we're searching for information relevant to oranges. So we read through the question quickly, looking for any information with oranges. A doctor tells a sick freshman to add bananas and oranges to his diet for vitamin A, B, and C. A pound of bananas contributes 8 grams of vitamin A, 6 grams of vitamin B, and 2 grams of vitamin C. A pound of oranges contributes 2 grams of vitamin A, 6 grams of vitamin B. So right now, we haven't seen it, but the opposite, we've seen not it. We see that oranges contribute no vitamin C. We also know that we would not be given a question that could not be solved. I wouldn't do that to you. You have to assume I wouldn't do that to you. So in this situation, even though oranges provide no vitamin C, it doesn't majorly impact the question. This would be a scenario where, for whatever reason, not everything is accounted for, but it doesn't negatively impact the solution because I gave you a question that could be solved even if it doesn't. So the answer very quickly is no. This is again a theory question that draws on general information given throughout my 7 weeks of lecture. It's the sort of question that asks you to understand the basic ideas governing linear programming problems. These are the kind of questions that it's difficult to prepare for unless you are willing to re-watch all of the videos. Hopefully you have absorbed a lot of this information. It's all been covered, but hopefully you've absorbed a lot of it through the course of watching these videos for the past 7 weeks. In the first homework question, the 2 decision variables are tax saver 1 and tax saver 2. So again, we know that we're looking for our options. A junior student earns $20,000 during her summer internship. Since she plans to pursue graduate studies next spring, she wants to invest all her earnings in an annual tax saver scheme and a non-tax saver scheme. So right there we see choices. If we see choices, we know probably we've found our decision variables. Let's go to the last couple sentences. How does the student maximize the return on her investment? So in that situation, we know we're investing. We need investment choices. Our investment choices are tax saver scheme and non-tax saver plan. So the correct answer in this situation is true. The 2 decision variables that we have to consider, the 2 options guiding our choices, the 2 things we have to decide between are tax saver 1 and tax saver 2. Oh, in this situation, that is incorrect. My terrible mistake. The options are tax saver and non-tax saver. So that is incorrect in this situation. But the basic theory on how to find it is still sound. Look for our decision variables. Look for the choices being made. In this situation, tax saver choice, non-tax saver choice. False. In the first homework question, there are 3 constraints. This is similar to a question we answered earlier. We have to read through this. We have to read through and assess. We have to read through and check what limitations are being given. Student earns $20,000. Since she plans to pursue, she wants to choose between tax saver and non-tax saver. The tax saver plan yields a return of 8% with a risk score of 3. The non-tax saver returns 10% with a risk score of 5. To use the tax exemption, the tax saver has to invest at least 50% of her investment. That's our first limitation. Because it's have to, we recognize right away that that's a scenario that cannot be ignored. If it's something that has to be done, it is a limitation, a constraint, a guideline, or a rule we have to follow. We also see the professor advises the student to keep her average risk score no higher than 3.6. So again, a rule, it cannot be higher than 3.6. So in this situation, how many constraints do we have? We have 2 constraints. The correct choice is false. Now, in questions like this, again, that directly reference a question, you have to be able to quickly read through, quickly assess the problem, and quickly determine what is being asked. In this situation, we see that it's asking where our limitations lie, and the answer very simply is there are 2 limitations, not 3. In the second homework question, the ingredients should have names to complete the question properly. The elixir drug company produces blah, blah, blah. We know right now from looking at the question that it's not in fact directly referencing the question, because we're instead looking at a theoretical idea. The exact same theoretical idea that we covered earlier. Do the ingredients need names? Do our choices need names? Does our limitation need a name? Or can we represent it with unknown variables like x, x1, x2, x3, etc.? And we know, without reading the question was a trap. It doesn't directly reference this situation. We know that we do not require ingredients to have names. Instead, it can be ingredient 1, ingredient 2, ingredient 3. It can be choice 1, choice 2, choice 3. It could be A, B, or C. It could be any one of 1,000 possibilities. The basic idea is that we do not need them to have proper names. Only some way of differentiating them from each other. Moving on. In the second question, there are how many constraints? Here, again, we have to look through, and instantly we have to look for limitations. So let's read. The elixir drug company produces a drug from 2 ingredients. Each ingredient contains the same 3 antibiotics in different proportions. 1 gram of ingredient 1 contributes 3 units, and 1 gram of ingredient 2 contributes 1 unit of antibiotic 1. The drug requires 6 units. Requires is key. So we know it requires 6 units of antibiotic 1. That's our first constraint. At least 4 units of antibiotic 2 are required. Boom, our second constraint, because it's required. And the ingredient contributes 1 unit of each per gram. At least 12 units of antibiotic 3 are required. That's another constraint. So there's a required number of antibiotic 1, a required number of antibiotic 2, and a required number of antibiotic 3. Those represent constraints. A gram of ingredient 1 contributes 2 units, and a gram of ingredient 2 contributes 6 units. The cost for a gram of ingredient 1 is 80. The cost for a gram of ingredient 2 is 50. So we've gone through the entire question. We saw only 3 constraints. The correct answer is B, 3. In a question like this, you have to read quickly through the question, and you have to determine what is limiting your choices. What must you do? What are you required to do? Attendance quiz number 11. in practice question 1, the correct objective function would be, now here we see that we have 3 possibilities. This is a question where the entire question does not have to be read. Instead, we can look at the first kind of couple sentences and the last couple. But this is a good example because it shows us sometimes we have to scan the rest of the question as well. We see they plan to charge $35 for a home driveway and $120 for a business parking lot in the second last sentence. But option number 2 is incorrect because prior to that, we talked about in the question, they talked about how we were in a situation where costs were given, revenue is given, but we're looking for profit. So we have to understand that even though we've found very quickly what we thought to be our objective function, we have to quickly scan the remainder of the text to double check that it is in fact our correct answer. In questions like this, as I've shown you, you can skip to the last sentence, kind of move through the first couple sentences, but you should always quickly scan the rest of the question just in case. Time should not be a tremendous determining factor. So you should have time to scan questions like this. If not, answer immediately, and then if you have time remaining at the end of your test, this is where you go back and check your answers. Attendance quiz number 11. Again, in question 1, the variable costs are relevant. And now this is directly relevant to what we just talked about. But maybe we have this question, but we don't have this question. So here, what we would have to do is read through the question, looking for that situation, variable cost. The WeMo Lawn Care Service wants to start doing snow removal in the winter because there are no lawns to maintain. Jeff and Julie Weems, who own the service, are trying to determine how much equipment they need to purchase based on the various job types they have. They plan to work themselves and hire some local college students on a per-job basis. Based on historical weather data, they estimate there will be 6 major snowfalls next winter. Virtually all customers want their snow removed no more than 2 days after the snow stops falling. Working 10 hours per day, WeMo estimates that they can remove the snow from a normal driveway in 1 hour, and that it will take about 4 hours to remove the snow from a business parking lot. The variable cost is $12 for a driveway and $47 for a parking lot. Boom! We found the variable cost reference. So it's the first time we've talked about this. So we kind of continue reading, and we see that variable costs have to be subtracted from revenue to find our maximum profit. So true would be correct in this situation. It is critically important in this scenario that we consider variable cost. This is a combination of natural language problem solving, problem translation, plus understanding guiding principles of linear programming. In question 1, the WeMos and college students both working is relevant to the problem solution. This is exactly the same as the last question. In this scenario, you're going to scan the question, reading quickly through, and determine if it is important. We see that this college student idea, the WeMos and college students working together, is covered in sentence number 3. They plan to work themselves and hire some local college students on a per-job basis. After that, looking at the rest of the question, we realize that that wasn't relevant. It wasn't important. It was information given to us, but it was not important to solving the problem. So, in that scenario, We look and we realize that no, it is not important. This is a problem just like this one listed previously, where we have to scan quickly and understand the basic principles guiding linear programming problems. Question 11, next question 4. In question 2, if the company is trying to minimize costs, the usual constraints will be less than or greater than or equal to, less than or equal to, it is unclear. Again, this is a situation where the question was given as a trap. This is a basic theory question that asks you to understand what is being asked. If we are, and we look at the question briefly because it does reference that, but we see that they're hiring permanent and temporary operators. If they're trying to minimize costs, they have minimum amounts that must be met. If they're trying to minimize costs, the correct answer is 0. 0 minimizes costs completely. But if we do 0, of course that's not acceptable because they have minimum standards that must be met. So in that situation, our requirements would generally be greater than or equal to because we have minimum standards. This is a theory question, again, that we've covered and calls on general information. There is no real way to prepare for questions like this. Instead, we're in a situation where you need to have absorbed this information, or you need to go back and watch the videos again. It is a situation that calls for a basic understanding of minimization questions. In question 2, 0.5x1 plus 1.4x2 less than or equal to 25 is a valid constraint. So we have to look for our limitations. We see near the end, the company wants to limit the number of mistakes to 25 per day. We go to the two sentences before that. A permanent operator generates about 0.5 claims with an error each day. A temporary worker averages 1.4 mistakes per day. They want to limit the number of mistakes to 25 per day. 0.5x1 plus 1.4x2 is less than or equal to 25. In this situation is a valid constraint. We see that now. So in this situation, in questions like this, if we see one of these points, 0.5x1, 1.4x2, 25, we scan the text, we try to find where those numbers are directly referenced, and we try to interpret from there, which allow us to solve problems like this quickly and efficiently. Attendance quiz 12. A constraint line on a graph shows where that resource is fully used, in usage, underused. Very simply, this is a basic theory question. Something I've covered again and again, and we know that it is a constraint line shows where the resource is fully used. A constraint line is very simply where we are using all of the resource. Basic theoretical knowledge that you need to have. All points on the graph that we have generated, again, basic theory. We have spoken again and again throughout the videos I've made of what those points on the graph represent. And they represent production choices. They represent possible choices. On a graph, any dot represents a combination of choices, or the choices on the x and y axis. What number of x1 on the x-axis and what number of x2 on the y-axis that we are choosing. Basic theoretical information. We have spent a lot of time graphing. We have spent a lot of time talking about graphing. This is information you need to be comfortable with. When graphing, each constraint should be graphed as a separate line. Again, yes. We have spoken about it. After we have drawn our graph, after we have indicated what the x-axis represents and what the y-axis represents, we then graph each and every one of our constraint lines. We cannot skip any. We have to draw each of them in. We have to draw each of them in to properly determine our answer. Attendance quiz 13. The only questions I haven't covered here are the ones that ask you to identify which graph represents which question. You will have some questions like that, but it's not something that we can prepare for here. It's something that you need to be comfortable with on the day of the test. In a minimization problem, the area where all constraints are satisfied is usually near where the x1 and x2 axis meet. So where x1 and x2, x and y meet at 0, 0. In a minimization problem at 0, 0, is this true? All constraints are met. The answer is false. In a maximization problem, that is true, because producing 0 makes us lose or doesn't make us use any resources. But in a minimization, the opposite is true. Where x and y meet, we haven't met any of our minimum requirements. Next question. We allow x1 to equal 0 to find the coordinates for x2 when plotting constraint lines. Absolutely true. This is something we've talked about again and again and again. With every time I have shown you a graphing example, I have shown you this exact scenario. To find our x1 and x2 coordinates, we need these two things to be true. Finally, our final attendance quiz. Attendance quiz 14. If there are 3 limitations guiding the question, how many lines will we see on the graph? Referencing this question here, each constraint should be graphed as a separate line. If there are 3 constraints or 3 limitations, we will see 3 lines on the graph. Again, graphing is not overly hard, so I did spend quite a bit of time discussing the theory behind it. You are responsible for that theory. These are things that you A, either have to know, or B, must rewatch the videos to acquire the appropriate knowledge. When graphing, how many points on a line do we require? Basic theory question. We let x1 equal 0 to find x2. We let x2 equal 0 to find x1. That gives us 2 points on the line. When we have 2 points, we can connect those 2 points and form the actual line. In a maximization question, the area above all the lines represents nothing special, the area where resources are a non-issue, the optimal production choices. Oh, this was a small mistake. Let's skip this question for now because it wasn't copied properly. In linear programming, the constraint lines represent where the constraint is fully met, where the constraint is not a problem, where the constraint is problematic. The constraint lines represent where the constraint is fully met. Basic theory. Where we are using all of it, where the minimum requirement is basically fully met. When graphing, each and every constraint, even if it does not affect the question outcome, needs to be on the graph. True every time. You need to draw in all of your constraint lines because until they've been drawn on the graph, we do not know yet if they will affect our optimal solutions. Basic ideas are you need a working knowledge of theory and practice. You need to know the theory governing break-even analysis, question translation, graphing, problem solving. You need to know this. You also need to be able to actually solve these problems. You need to know how to solve break-even analysis. You need to know how to solve or how to graph. You need to know how to write our basic natural language questions into equation format. And you need to know how to solve like we did last week. This is all part of your midterm exam. The midterm exam is an online test. It will be written using classmarker.com. You can take the test from your phone. The test will be randomized. You will not have the same test as anyone else. Your test will be unique to you. Time will be an issue. If you are taking time to help other students, it will affect your grade. If you want to try and work together, you can. It will not help you. Your test will be totally different from everybody else's. I have taken the time to enter a huge question base to ensure that nobody has the same questions on their tests. So, please don't waste your time trying to work with others. Use your time effectively and use your knowledge to try to solve the problems. For your test, you will be given an individual registration code next week. You will not get another code. Keep your code secret. If someone else enters your code, you will have no way to enter the exam. In that situation, you will get 0, they will get 0. This is critically important. Protect your code. I will give it to you personally through Cacao next week. I will send it to you personally. Do not lose it. Do not delete the message. It will be critically important to entering the midterm exam. The exam will be 50 minutes during your regular class time. It will be held next Thursday. It will begin when your regular class begins. It will finish 50 minutes later. Please watch this video in its entirety. All of what I've said today is very important. If you have questions, you can contact me. However, if your questions were covered in this video, I will not be giving you an answer. Thank you everyone for listening. Have a wonderful day. On Thursday, we have no class. Oh, that's something I will cover in text message format. Thank you again for listening. Have a wonderful day.